G'day guys, it's Adam Kogan here at NDC. Well, actually I'm in the SSW TV studios, but we are streaming a track of NDC and it's been a lot of fun, not as good as being in person, but as good as it can be during these coronavirus times. And JK did a session on ML.NET. How are you, JK?
Great. NDC Sydney was really good, despite being only virtual.
Yes, you're not actually in Sydney, are you?
Now I'm in Brisbane at the moment, at home.
Okay, awesome. So we're going to be talking about ML.NET and how that is targeted at developers. But I know you love all this stuff, and I just thought I'd bring up that you are now an MVP of what?
AI, so AI MVP.
Yes, all right. So that is one of the best titles you can be as an MVP. So congratulations, JK. And
Thank you.
I want to just start off by saying, look, ML is targeted towards developers. Now that means it's Visual Studio friendly and C# friendly. Is that right?
That is correct. Although recently they also added VS Code support.
Oh, okay. All right. Are you doing your stuff in VS Code or Visual Studio?
At the moment, Visual Studio, as it has more power, but VS Code can be a very good alternative for people who are on Linux and Mac.
Okay, all right, perfect. So help me understand, like a lot of people that get into machine learning go with TensorFlow and Python and Onyx, and why would you go with ML.NET from the Azure team?
So if you work with .NET a lot, then it's kind of a no-brainer from the perspective if you just want to get a jump on machine learning, want to understand how machine learning works, and just make a prototype, see how it goes, and then push it all the way where you can have it in production. Whereas if you go TensorFlow and all the other machine learning, it can be a bit daunting. They are improving, just like all of like ML.NET. It's making more approachable, but I think ML.NET, at least for .NET developers, is the most approachable machine learning framework at the moment.
Okay, all right. So we'll come back to a little bit more about that, but I'd like to ask, just in general terms, scenarios that are great for machine learning. So look, I know that you can pass in, pictures and it will recognize an object. It will know, hey, is that a banana or is that an apple? And I know that, you built our Sophie tool where you walk in from the front and it recognizes that I'm Adam or, I'm Raj or I'm Mehmet. So it's very good at doing all that. But what are some other business scenarios of machine learning?
So there's quite a lot of them, but just to pinpoint a couple of, for instance, for developers, if they happen to have unstructured logs, for instance, from an old legacy application, and they need to be able to, classify the logs, what is important, what is not important, what is an error, they can use machine learning to basically try to assess that from the text itself. So they wouldn't need to write regex and stuff like that to do that. And when new logs comes in, new types of logs, it may still work correctly without needing to change anything. And if it does need to change, all they need to do is add this to the training data and mark them correctly.
Rightio.
Yeah, and there's a lot of other opportunities. We have product recommendation. We have, say, the likelihood of somebody being willing to do business with you based on their, say, how much budget they have. For instance, that's important for consulting. What technologies they want to use, what is the complexity of their project, are they government or not, and things like that. You could then have a gauge, for instance, how likely it is for them to work for you.
Right, and you just mentioned product recommendations. Is that one that you would build with machine learning, or should you use, there's built-in pieces of cognitive services that are already built, isn't that right?
So yes, there is a cognitive services for that, and that service is really good. However, if you need to run this on-prem without any external access to Azure, then ML.NET gives you the ability to run it offline.
Okay, but if you don't need that, you just use what comes with cognitive services, right?
Yeah, I would recommend cognitive services, especially for the beginners.
Yes.
And the ones that are not too comfortable with machine learning. The power of machine learning is it's more of a white box opposed to cognitive services black box. So if you need to do some extra adjustments to your training algorithm, it's easier to do with your own than with cognitive services. But we're talking about really advanced scenarios. If you don't have advanced scenario, then cognitive services is almost always the right answer.
And what are some other scenarios that are kind of machine learning scenarios that you shouldn't be doing because they've been sorted out by generic frameworks?
Well, we have Azure Search. We have, like, you can do ML.NET object detection, which is what you were mentioning before. But that is actually using Azure behind the scenes. So you kind of are using Azure. And I would say most of the things that are in cognitive services can be done with the machine learning. It's more about, do you need extra customization?
Right. Okay.
That is beyond the service.
Okay, so JK, let's just talk about your journey for a minute. I know that when you first started off having a play with machine learning, you were trying to save some money, right? And
yes.
If you wanted to save some money, then you put all your expenses into machine learning and you started doing some analysis to see, I assume, where you might be spending money and where other things are going on. So tell us about your first experiences.
Yeah, so just to give a little bit of context, before I went to machine learning, I had an Excel sheet. And what I have been doing is that basically I manually added all of the transactions in Excel and manually put them into categories so that I could see percentage-wise where I'm spending the money, so that I know on which category of transactions I should be focusing to save money. With machine learning, what I managed to do is I was able to automate that. I was able to just have an Excel of existing transactions. I just added a column of what should be the right category, and that has been updated every single time I retrained my model, which saved me, no joke, more than 5 hours every week.
Right. Okay.
So it's tremendous, at least for my case.
And tell us, what did you learn? Did you actually end up saving any real money, or say, did you get any insights?
What I was able to do is be more reactive. So basically, I was able to get data faster. And for instance, there was a case where I noticed, hey, I'm spending a lot of money on groceries. And then I looked at, okay, the last couple of purchases were high. And then I could verify, is this something that I should be expecting? Have I actually purchased something that is expensive, or should I be tracking that and make sure that the next grocery shops should be cheaper?
All right, so tell us a scenario where it hasn't worked, like when it was classifying and it wasn't working out its right answers.
That was when I bought my gaming rig. It's a pretty beefy desktop, and when it got classified, it was classified as a bank transfer between accounts. And I was like, that shouldn't be right. It should be under gadgets. And when I looked into it, what happened is it was one of the highest transaction values, and any other high transaction values were bank transfers. So machine learning made a shortcut saying anything that is expensive should be just bank transactions.
Oh, right. So the amount being spent was the biggest influencer. So anything that were thousands of dollars was just assumed that's a bank transfer.
Yeah, exactly.
Okay. So what did you do to solve that problem?
Well, then I actually learned that, hey, I don't actually need the expenses column. It gave me almost the same accuracy, so I removed that column. However, there is a story about why sometimes you want to have the expense and why sometimes you want to have two models instead of just one, if you want to
So
hear.
hold on one sec. I'm just trying to understand the transfer example. Does that mean that you didn't have enough training data, or like I understand your
Yes.
answer was to what was it to kill the dollar amount?
Yes. So the data that I have was very biased with low values, so tens of dollars, hundreds of dollars, but nothing in thousands and tens of thousands. So if I get any one transaction that breaks $1,000, it would likely be misclassified because everything is biased towards smaller numbers, and everything high was just shortcut to be bank transfers.
Rightio. Okay, so you took off the dollars, and then that meant it worked fine.
Yes, except for Uber. For
Oh,
Uber Eats and Uber Taxi, Uber Travel. And
oh,
the
what? The descriptions weren't enough to tell it one was food, one was not.
Yeah, so they actually fixed it a couple of months ago, but before that, the transaction description for Uber Eats and Uber Travel were the same. So what I had to do is build a second model that says, okay, if I have any transactions that been classified as Uber, put this into the second model and add expenses to it as well, because there was a trick. When you had Uber Eats, you had expenses in .25, .20, 49 cents, 99 cents, whereas taxi drives was more chaotic because you were driving, so the cost was directly related
Ah,
to
right.
the distance.
So,
And what
Uber taxis, they are all over the place depending on where you drive,
Yeah.
and that you can't really tell from the amount because
Mhm.
you might buy a lot of food or a little amount of food. But
Mhm.
you're saying that when you're buying food, they're usually ending in round figures like zeros or 50 cents or 25 cents. But
Yeah.
okay, all right. So that's fascinating. That's really good. All right. So how beefy is your PC to run this stuff? Are you running it
Ah.
all in the cloud, or where's your training models?
So right now I'm only dealing with a couple of thousands of lines of data. So my desktop, which is AMD Ryzen 5 3500 with RTX 2070 Super, which I'm using for virtual reality stuff as well. Um, it's really good for the data that I'm using. Now, if I would have to scale over hundreds of thousands of lines, then this is where I would start using Azure. So
Right.
this is
Yeah.
where my machine would probably, it would be sufficient, but it would also mean that I wouldn't be able to use it. So I would prefer to move it to Azure. But right now, leaving it for 2 minutes to do the training is acceptable for me. It's for free.
Right. But if you were dealing with tens of thousands of images, this is a completely different story, isn't
Yeah,
it?
that would definitely go to Azure.
Rightio. Okay. All right. So, what has been the hardest thing to get your head around with all this machine learning stuff?
Oh, so yeah, that's a tough question, but to easily answer that is when you try to learn machine learning, you don't even know where to start. You don't know what you need to learn, and you don't know what you don't know. And when I wanted to do back and bank classification demo over the weekend, that was about 4 years ago, or even five now. I was learning machine learning, and I was I have learned a lot about it. I understood more about machine learning than ever. Only for 4 years later, 2 years, sorry, later to realize that I learned the completely wrong thing. I was learning regression, which is to predict prices of houses. I learned clustering, which is for doing product recommendation, but I should have learned classification, specifically multi-class classification. And this is one of the biggest problem with machine learning is just unless somebody tells you, for this scenario, learn this, it's really hard to get into.
Right. Ah. When we are using products such as Teams or SharePoint or Office or whatever we're using, is there any parts of it that are already using Azure's machine learning?
To my knowledge, yes. But I don't think they actually published anywhere what exactly they're using for.
Right. Okay. Ah, all right. So can I take you through a bit of a scenario I'm just thinking of? If I look at our dynamic solution, we have an entity in there called opportunities. Every single person that rings or emails us goes in there, and we give a whole lot of attributes. We put their name, their location, what type of solution they're looking for. They're looking for this type of solution. How much their budget is, where they heard from us. Did they hear about it from a friend who had worked with us, which we call a referral, or was it a Google ad, or did they drive past our office and see signage? All these, we've got so many things that we know about every single one. We know whether we won the job or didn't win the job, etc. So you kind of, what would be involved if I said, hey, I would like a control there. I don't know, maybe
like a gauge?
Like a gauge, yeah, perfect. I want a gauge, and if this client has a high chance based on prior data, put the gauge right over there, green. If they're a low value, which often I know happens to be from Google Ads, put them over down there. What are the steps involved in doing all that? Is it a huge task? Is it a quick task, etc.?
This one actually, it would be pretty easy because all you need really is having it in a SQL table or in a Excel. Then we can import it in ML.NET. And in this case, it would be a binary classification. So we would get a zero value between 0 and 1. 0 being it's not likely that you'll get that you will be able to win them, and 1 that you'll be able to win them easily. And you just train it and try it out. See with all of the historical data that you have, if it's better than say 70%, because if it's better than 70%, it's better than chance. So if you have a new client coming in, you can already see, hey, the algorithm says it's 80% chance that you'll be able to win the client. So make sure that you win that client.
Right.
The algorithm is on your side.
Okay. So
although to be fair, what you can do is rig the machine learning a little bit for the managers, tell them that adds a little bias toward winning, because confidence can actually be the winning factor.
That's terrible, JK. So you're saying just tell them they're going to win, they'll be more enthusiastic. It's probably an interesting thought there. That's hilarious.
It gives them validation.
Okay. No, that's a terrible idea. We have to do a class on ethics now. But yes. What experiences have you had about garbage in and garbage out? Like, let's just say that I think those factors matter, but I'm missing a major factor. How do you work out, like, have you experienced this, that you're just collecting the wrong data? Or, like, I know before I found it fascinating when you said I deleted the dollar column, which would be the last thing I would think of doing if I'm trying to analyze which accounts, amounts should go. What's your experience with garbage data?
So yeah, I have quite a bit of experience with that. Now, for instance, with the bank transactions, a lot of people would say, here, why not add a date, right? Date feels like an important data, right, for bank transactions. But what it turns out, unless you're doing forecasting, or if you make the dates like quarters, day of the week, and things like that, it's actually worthless to the machine. In fact, it makes it worse. It makes it less accurate because machine learning has no idea what to do with incremental values. And any columns, any data points that have nothing to do with the thing that you want to predict, it will just make things worse. So yeah, what I do is I just remove the columns and see, do I get better results? And that's what is really powerful with ML.NET, especially the model builder, the Visual Studio extension, is I can just say, I don't want this column. And I can quickly retrain, see how much better or worse it got, and then go quickly back and say, remove another column or add another column. I'm even thinking about automating this so that you just leave it for a couple of minutes and it will tell you, hey, just remove these columns, they're worthless.
Rightio. All right. So I'm still thinking about your answer on the prior question, where you said what you could do is just bump up the confidence level, or bump up the gauge so it gives them more confidence. You could do that as an A/B test. You could say, all right, so I'm going to bump some down and bump some up and see if it actually does change people's behavior. Store what you bumped up on a random A/B test and then see if that actually is a major factor, their confidence, more than whether whether the data tells you that you'd win the job or not.
Yeah, in fact, you can go even further. You can actually have A/B testing with two different models. So one model maybe looks at all of the attributes on everything, the whole picture. It might be less accurate, but it looks at a wider picture. But then you have the other one on B, which focuses on only specific columns. And then you can see, is the one that looks at everything more accurate than the one that is very focused? And what we might see is there'll be probably quite a bit of consensus between those two models, but when they're completely off, this is where you might want to check and see why they're off, and maybe you can get some hints on your data that allows you to improve your model even further and make and have even better accuracy.
Amazing. Yeah, this is a really fascinating topic, and it's just like an endless topic. How often do you see developers solving a problem like that is taking a lot of effort, where machine learning would be a perfect answer for this?
I'm still quite new to this, so I'm seeing a little bit in that. Let's say I see this a few times a week, where we could just replace a certain logic with machine learning model, and then we could get, say, like a auto suggestion for the user. Or say for timesheets, when people are entering timesheets, we could basically make a machine learning model where it basically gives you a suggestion. Hey, this is the timesheet you might want to enter based on all of the data I have. Or we have the sugar learning, where we have what do we need to learn for induction to better understand all of the processes. And we could do like a product recommendation where you see all of the items that you have completed and what others have completed in what order, and it could give you a suggestion which would be the next learning item for you to learn. And this is applicable really for any learning systems, for education and stuff like that. And I'm really excited to get new clients, because we're currently working for one for auctions, where I'm like, I see like 5 to 7 things we could do with machine learning.
Yep.
One of which is trying to predict when to bump up the Azure functions to a ridiculous amount, because they're going to have a really, really high traffic in the next minute, because everyone's going to start to bid. And then when
yes.
down.
Yeah, it's amazing.
And that could be done with machine learning, and it could, in their case, it could literally save them thousands of dollars.
Yes. And I liked the example you used before for essentially validation. So that if you're saving a record, like we write a lot of logic now, hey, if this, do this, don't, like a lot of it this record could be passed to the machine learning, and it says, look, this timesheet just looks wrong. You never go to this location and work this many hours. This just looks like an outlier. Do you confirm? That type of stuff. So yes, yeah. So that's awesome. Okay. So JK, do you think is there anything coming up with in the machine learning world that you're quite excited to look at or investigate further?
So one of the things that I'm super excited is about Blazor in .NET 5. And the reason for it is because we can now run ML.NET in Blazor. And I did a demo for it, and it's just amazing. We could literally build an application that is fully offline and AI-enabled, written in C# and running on a browser.
And you're doing you're doing some Blazor projects at the moment, aren't you?
Yes.
Are you enjoying it?
Oh yeah, it's amazing, and most of my pet projects are also all in Blazor.
Okay, so just give JK a Blazor project with machine learning and you're in heaven.
Yes.
All right. Okay, well, it's been great talking to you, JK. I'm getting back to the NDC live stream, but I hope you have a great time for the rest of the conference, and I hope you do a lot more ML.NET over the next year. And this is Adam Kogan signing off for SSW TV.